In this problem, we're looking for all of the angles theta in between 0 and 360 that would make the left of this equation equal to the square root of 2 over 2. So right away I have a lot on here, and so I want to try and find an identity that would simplify this into a single trig function. And so if you look at the pattern sine, cosine, cosine, sine, and compare them to the identities that we found, I know that this is either going to be a sine difference identity or a sine sum identity. Sine, cosine, cosine, sine for both of these. Now in our problem we're subtracting the two terms, and so that tells me that we're dealing with a sine difference formula. And so instead of looking at this with sines and cosines, I can rewrite this as the sine of the first angle, 5 theta, minus the second angle, 3 theta, and set that equal to the square root of 2 over 2. So now our equation just became a lot simpler, and so I can combine the 5 theta and the 3 theta, so I'll have the sine of 2 theta is equal to the square root of 2 over 2. Now, before I get too far into this problem, I want to look at a graph so I have an idea as to how many answers I'll need to find. And you can see here that in between 0 and 360, I'm going to have 1, 2, 3, 4 different answers. And so keep in mind that we're going to find a starting point here. Once we find an answer, we can add or subtract to the period to find another one. Same thing here and here. One thing before you start to find our answers for theta is you may want to make note that our period is going to be half of what it normally is. And since I have a 2 in here, the reciprocal of 2 is a half. And so right away I'm going to multiply that by 360, my normal cycle size, and I'm going to get 180 degrees. Keep that in mind, so when you go to find more answers, they're going to be 180 degrees apart, which is different from a normal sine and cosine graph here. So I need to find the values for where the sine will equal the square root of 2 over 2. You could use your calculator for this, or you could simply look at your unit circle. And I know that sine will be positive in the first quadrant and also in the second quadrant, and that will be at 45 degrees and again at 135 degrees. So right away I know that the inside here, 2 theta, will need to equal 45, or it will need to equal 135. And so again, now I need to divide by 2 because I'm not looking for where regular sine equals this ratio. I'm looking for sine of 2 theta. So I'll divide both of my answers by 2, and I'll end up getting theta to be 22.5 degrees. And then I'll also get theta to be 135 divided by 2, which is 67.5 degrees. Okay, when we looked at the graph before, we saw that we needed 4 answers, and so I need to add multiples of the period to each of these, which again, normally is 360, but in this case, since I have a 2 in with my angle, is going to be 180. So I'm going to end up getting here 202.5 degrees, and then when I add 180 to my 67.5 degree angle, I'm going to end up getting 247.5 degrees. And so my final answers are going to be the 22.5, the 202.5, the 67.5, and the 247.5. And so again, you could verify this with the graph. This seems reasonable to be 22 degrees, 67 degrees, and then our other one was 202 degrees and 247 degrees here. So we're done, and we found all 4 solutions.